Entry solution, engineers use the plane's computer systems to cancel out the vibrations. They call this computerized system fly-by-wire, a huge improvement on the cables that used to control the wings.
A pilot input would cause a cable to move, which would, in turn, signal to the surface to move. A fly-by-wire system is where you've got computers in the loop. It's where a pilot will move the column, turn the wheel, and when they do that, it sends an electronic signal by a wire to the actuator that will control the surface. Now, what that allows you to do is put more computer and more flight control software technology into the handling characteristics of the airplane.
They can use the computer system to make tiny changes to the wing controls to cancel out the flutter. It's a simple solution in the spirit of Joe Sutter's Incredibles.
I have an immense amount of pride working on a product that Joe Sutter and his team effectively designed, built, and tested before I was in kindergarten.
In 1968, Joe Sutter and his team of Incredibles give the world the most iconic shape in commercial aviation history. That famous hump. But they don't design it as a first-class retreat for the jet set. Because Boeing thinks the future is supersonic, they see the Jumbo's future as a freighter.
So luckily, the passenger requirement for 350 passengers and the big freight capacity requirements blended together, so we could build a fairly optimum airplane for both the passenger role and the freight role.
Getting passengers on is easy. Getting large cargo on, that's a challenge.
We looked at a lot of different schemes, and one concept was to put a nose door on the airplane, or some way of loading freight from the nose.
In a radical design move, cargo will enter through the nose. This places the flight deck above and out of the way. And so that famous hump is born. Pan Am President Juan Trippe immediately sees the potential.
Juan Trippe turned around and looked at this area and says, "What's this used for?" And his chief engineer said, "Well, it'd be a good crew rest area." And Juan Trippe looked at the engineer and says, "This will be reserved for passengers." And that's how this upper deck that we now fly on came into being.
On the new passenger 747, that iconic hump has expanded to the length of an entire 737. Back at the factory, work is progressing on the fuselage. It's built in several sections: rear, middle, and the front, with that famous hump. Each section is assembled panel by panel. All the body panels are coated with a green protective vinyl to prevent damage during construction. Only the nose is made as one piece. The lower part of the main body is built upside down for easier workflow. Then it's rotated 180 degrees in a special turn fixture so they can put on the roof. Once assembled, it's so unwieldy, only a mammoth 34-ton crane can lift it. A total of 26 cranes on 50 kilometers of ceiling tracks fly the sections around the massive complex.
You gotta tell all the airline pilots that, hey, we flew them first for you. We can just pick it up and fly it wherever it's gotta go. Set it back down and people get to go to work on it. There are a couple people that have a fear of heights that are in this job, but it's best if you don't.
Before the fuselage pieces are moved to their final assembly position, it's critical to make sure that nothing is left behind. A loose bolt could cause a disaster if it rolled into the wrong place, such as an engine or even one of the fuel tanks.
Every rivet, every fastener you put in, it could be a critical item. I remember an old saying I heard years ago, quantity is something you count, quality is something you count on.
It's 2 a.m., but Boeing never sleeps. Inside the world's largest building, an extremely complicated maneuver is underway. So far, the Dash 8 team has built her wings and her fuselage. Now it's time to bring it all together. To make this Dash 8 look like a jumbo. Joining up the three sections of the fuselage is one of the most demanding jobs in the entire assembly process, which is why it's done in the dead of night. It's safer, fewer people on the floor, less chance of something going wrong. With millions of dollars worth of aircraft parts coming together, this is an extremely delicate industrial dance. The ground crew have to pay attention to the smallest details. The crew are positioning the forward section to receive the wings. When lowering a section, the team must be precise.
To line up to make sure that we set in the cradle at the right position. It's a matter of a quarter inch either way.
The wings are now joined to the center fuselage. They span almost the entire width of the factory floor. Two tractors must pull at exactly the same speed to stop the wing section from veering off into the sides of the factory. The clearance between the walls and the wing tips is just 5 centimeters. Next, the tail section joins up with the rest of the plane. The characteristic jumbo outline is taking shape. She's 76 meters long and 68 meters across. Thousands of hands have got the aircraft to this stage. The task of managing and organizing such a large crew isn't easy. But it's something Boeing has had plenty of practice at over the last 40 years. During the early years, Boeing faced a financial meltdown. It came close to bankruptcy. There were layoffs and pressure to halt development. Running the 747 program was a real challenge.
We were working very hard to get all of the drawings out at that time, so the engineering department was peaking out at about 4,500 people. I was asked to make a big cut in that. We needed 800 more engineers. I think maybe I'm going to lose my job today, but I'm going to tell them the way I see it. I figured that was when I did the best job I could have for Boeing. If I had reduced the engineering force, the whole program could have tumbled.
The latest jumbo jet program also has the potential to tumble. In 2008, Boeing's machinists go on strike for 2 months, throwing an already tight schedule into disarray. Each day lost costs Boeing $100 million. Added to the wing engineering issues, Boeing is forced to delay delivery by 2 years. Some buyers cancel their orders. But Boeing's immediate concern is to finish this one. It's time to give her some power. Time for the new engines. 4 revolutionary ones. The old 747 engines consume over 12,000 litres of fuel per hour. With oil prices at an all-time high, airlines are seeking any way to minimize fuel consumption. Finding a more efficient engine is critical to the Dash 8's success. General Electric is at the forefront of jet engine design. These brand new engines are the most efficient they have ever made. Boeing challenged GE to adapt them for the new 747. But they don't come cheap. With a list price of $20 million each, these engines are the new Jumbo's single most expensive component. But they are worth every cent. Composite materials used in the fan blades and casing trim 180 kilograms from each engine. Multiply that by 4, and it equals almost 10 extra passengers. And with fewer fan blades and lower turning speeds, these are the quietest engines GE has ever made. They can push through more air with less work. And that means burning less fuel. So how do they do that? Only 10% of the air is mixed with fuel and burnt in the combustion chamber, driving a series of turbines that power the big fan at the front.